All right, we'll get this show started. It's just past 2 o'clock. Welcome to the Smart Cities, Smart Solutions, Biogas, and Municipal Projects. I'm Jeff Van Vorst. I'm a project leader for Mead & Hunt. We're an EPC firm based out of Wisconsin. And we're going to introduce our esteemed panel here today. And they're going to give a little bit of an elevator speech because I think most of us are staying in a hotel with an elevator and you're running into people in that up and down ride. And you have that awkward moment where are you going to look at the buttons? Are you going to look at the numbers? Or could you talk to the person that's standing right next to you? So we're going to practice elevator speeches here today, and that's going to be their own introductions to you. And we're going to end with one thing that you can remember them by that maybe isn't exactly pertained to business, but more to their personal life. So for example, when I do my elevator speech, introduce my background, I would say that my favorite pastime is all things water sports. So anything behind a boat, any lake, any time, any boat, any activity, I'm in for, except if the water's frozen, then I'll choose a different activity. So with that, I'll turn it over to Noji, and she will pass it on to Chris and then Will with their elevator speeches, and then we'll start the panel discussion.
Hi, I'm Allison Nojima. I go by Noji, and I am with Brown & Caldwell. We're a consulting engineering company. I am our national energy specialty leader, so I deal with anything biogas, but dealing with a lot of municipal clients as well as in the private sector. So excited to share perspectives with you all on a lot of the municipal clients that we work with. Something to remember me by? I grew up in Hawaii, but I do not surf.
Hi, my name is Chris. I'm the founder and CEO of Burnham RNG. We build, own, operate renewable natural gas projects with a primary focus on wastewater, industrial food waste, and particularly with the municipal sector. I like the topic here. They call it smart cities and smart solutions. I think we think of ourselves as a solutions provider for municipal clients as they try to navigate resource recovery. We're backed by Ares Capital Management, one of the largest and most experienced infrastructure funds out there. Oh, and fun fact, you talked about ice and swimming in the ice. I just bought a cold plunge, so when I'm not in Savannah, most mornings I'm freezing my butt off before I go into work.
I am Will Charlton, President of Digester Doc, CEO of Valkyrie Analytics. We basically take care of the digester feedstocks and analytics, making sure the biology and the chemistry in the digesters is doing what they're supposed to do. Help processes make more energy, essentially. Over the years, we've run probably more BMPs than most people can imagine, probably in the names of thousands, different feedstocks and such. But fun fact about me, I grew up in Canada, so of course hockey is my big thing. But aside from that, I actually rode bull when I was younger.
All right, thank you all. Remember those fun facts. It seems like the theme is maybe temperature based, right? So I don't like if the water's frozen. Chris does like almost frozen water. Noji wants to escape to Hawaii where the water is perfect to surf in, but she doesn't surf. And will escape from Canada is how I'm reading this. So that's maybe the theme for today. So moving forward, I figured we just start with, so we'll keep this as a panel discussion today. The agenda will be to address some key questions on this topic. We'll let the panel chime in on their own experiences, their own thoughts, provoke things for you to think about. And then at the end, we'll have 15 to 20 minutes for you folks to ask us similar questions that can build off of what we talked about today. So we'll keep it very interactive at the end. Feel free, when we get to that point, feel free to come up and use the microphone. If you're very loud like I am, feel free to shout it out and we'll try to address those questions. So figured we'd start with, am I going the wrong way? There we go. How do you define smart cities? So that's the topic of our discussion. But if the ABC came to us as the panel and said, "Hey, we need to post what that means on our website." How would we define smart cities when you're dealing with biogas? So I'll let the panel run down the line and give us their own opinions on how we would define smart cities utilizing biogas. Noji, I'm going to give you this one first.
All right, I'm up first. I guess when I think about some of the smarter cities that I've worked with, I think about, the wastewater treatment plant having a resource, which is biogas, and having to beneficially use it instead of flaring it. Some of the clients that we work with, who I would say are maximizing their resource, are like looking within other city departments to say, like, who can use this biogas? Like, is there a fleet that's upgrading to RNG, so that we can work together to beneficially use biogas and also lower our emissions? I think it tells a good story for that city, or the transit agency and the wastewater plant working together.
Yeah, mine won't be too different, but I would say that the way I think about it is smart, if I'm a municipality, is viewing my waste as an asset. Maybe I'm a finance guy by training, and that's how I think. But it's an asset that can be recovered. Both the biogas, whether you have a municipal wastewater treatment plant, whether you have a landfill, whether you have organic collection routes, start thinking about that as an asset for resource recovery. Not just biogas, but I mean, frankly, the digestate or biosolids that come out of the back of the digester can be recirculated for nutrients, potentially clean water.
For me, a smart city is one that's sustainable, motivated towards innovation and profitability.
All right, thank you. Well, hopefully someone took notes and they can post this somewhere as our new definition of smart cities. So when we were talking about this topic beforehand, we were kind of bantering back and forth, and where do we start with this conversation? It's a pretty broad topic, and we kind of talked about what are some of maybe the key topics or key issues that we see in the municipal market when it comes to biogas, and we kind of narrowed it down to a couple general topics. And I'll let Will maybe start first here, from the science side on what he sees, and then we'll move on to the contracts and other client feedback. So Will, why don't you tell us what you were thinking when it comes to using science?
Yeah, so I mean, anytime you're dealing with municipal and co-digestion or any other additional feedstocks to make municipal projects more viable, you've got a lot of unknowns. You've got unknowns in the feedstock about what they are, how much energy they'll produce, how viable are they in digestion, is it something that's going to create problems with the settling in the digester? You've got so many different variables that you need to account for to make sure that the project is viable and applicable and that's going to be profitable. And we try to, as much as possible, utilize the sciences to answer those questions and make it easier for the folks that are developing the projects to be able to make those projects work and successful.
Thanks, Will. And then moving on, we kind of got into a little bit of a topic about, the infrastructure, and it's, basically there's some capacity, valuable infrastructure that's there when we start talking about these projects. And Chris had some comments about, how we can utilize that as an asset, what they have, and then looking forward into the future.
Yeah, so what you see on my left is kind of how we think about the wastewater treatment industry, right? And so, I think right now, wastewater treatment plants in most of the country, the vast majority of them, they have one job, and that's treating wastewater and putting clean wastewater back into the river or wherever they put it, and usually throwing away biosolids or potentially land applying biosolids. That's kind of how it works today. More and more often, as I think everybody in this room knows, there's the capture of the biogas that comes off of the digester. In many cases, for the right size digester, that's a no-brainer, especially if you're on a gas line or if you have other opportunities to utilize the gas. We help our customers work through that all the time. The other opportunity, which I think is happening in limited places, but my guess is will happen more often if you're looking at a 5 to 10 year time scale, is acceptance of other types of waste. And digester is also an underutilized asset, in my opinion, that a lot of these might not have optimized solid retention times, hydraulic retention times. They might have additional capacity available in their digester to digest organic waste, which increasingly there's a demand to separate that and recycle that waste and to create clean, renewable biogas from it. And so putting that in the existing digester, maybe as a precursor to building more digesters specifically for high solid food waste, is something that more and more smart cities, I think, are starting to look at, as well as upgrading the biosolids out of the back end to be either a Class A biosolid or any other kind of upgraded fertilizer product.
So when we started talking about this, Chris is like, hey, I got a great example I'd love to talk about. So I'm like, perfect. Like, people love case studies. We love to hear what were challenges and successes. So Chris, tell us a little bit more about your Pascal project.
Sure, thanks. So yeah, this is, I think, a great, for at least from my perspective, a great example of kind of what we're all about and what we try to do on behalf of our municipal clients. Jason Malloy sitting in the front row, he's the general manager of this facility. But this was, a municipality that had a problem, right? They had, or maybe an opportunity, the way I look at it, in that they were rapidly growing. Had a lot of, and still do have a lot of agricultural processing in their city, had previously been land applying all of the wastewater that comes out of this industrial park. It was an agricultural industrial park with 5 major processors. They were very successful and recruited a 6th. You see one of the logos there is a firm called Dairy Gold, the largest milk co-op on the Pacific Northwest, is building a new $600 million facility there in Pasco, Washington. They did not have the existing capacity to treat all of the wastewater, and all of the other processors that are there, Simplot, Research, others, were expanding their capacity. And so we talked to them about, look, they wanted to obviously keep wastewater treatment costs down. Who doesn't? We talk in terms of net wastewater treatment costs. So, I mean, you're not going to not have a cost for wastewater treatment, but what you can have is a lower cost because you're able to monetize and commercialize the biogas and other co-products that are valuable. So in this particular case, we signed a 30-year, we won an RFP, signed a 30-year tolling agreement with the city in order to take 100% of their industrial wastewater. That's that under construction right now. We give it back to the city in a cleaned up state. Well, we will give it back to the city. As you can see, it's about 70% complete, but we'll give it back to the city. And they use it for land application. So it's a really nice kind of circular economy story. We're not only monetizing and selling the biogas, but also reusing the nutrients. We take out a lot of nitrogen, but not all of it, so that some of the nitrogen can go on the crops. And we provide over 1 billion gallons a year of recycled water for agricultural reuse. And so we're very proud of that part of the project. I'm not sure who's in the room, so just want to thank some of the partners that I know are here at the conference today. Swinnerton is building this project for us. Biogas Engineering is leading some of that, and then Evoqua Xylem. Those are their BVF low-rate anaerobic digesters that are being used.
All right, good stuff. I'm sure you'll get some questions on this project later, Chris. So, and then Noji, with your background with environmental engineering and being, forward-facing with municipal clients, what kind of feedback are you getting from them when they get into these types of projects? Maybe it could be contractual. What are they saying are key topics or issues that they're concerned with?
For like the municipalities, they, all of these projects need to be economically viable because they're using ratepayer dollars to fund the projects. Typically at a wastewater treatment plant, a lot of the capital projects are either to improve the condition of a facility, to meet compliance or your permit. Whereas for all of these biogas projects, they're discretionary. And so we do have to see some type of return on investment. And I think that's a big key in working in the municipal space, making sure that you do see return on investment. I guess some of the other risks are covered later, but I do see more clients participating in cogeneration projects over RNG because of the uncertainty in RIN prices, or maybe not being fully educated in that space. And so it adds to their decision making with some of that uncertainty in market pricing.
All right, good stuff. Moving on in this discussion, we started taking a look at market drivers when we're talking smart cities, biogas, creating biogas. How can we continue to drive this forward? So some of the key topics we discussed are listed here, and I think we'll start maybe with what other waste streams could we be talking about, and how would we understand what the impact would be? So I think Will can probably describe what he does in this lab. They're definitely not bartending in this lab. They're doing something else. Maybe you can tell us what you're doing.
Oh, so the top picture on the left side there for everybody is the BMP units. We've actually got about 20 of those systems, so we process about 300 analytics at a time. In the middle fixture, we're actually just looking at some media, different biological media, and looking at what population bases are there. So a lot of the work that we do is chemistry and biology to make sure everything is running well. And this is just a couple snapshots from the laboratory.
I'm just curious, Will, what's the duration that you require to be able to do that type of testing and to get results that, Noji and her team and Chris and his team could use to help build a project?
So a lot of the testing that we work with is everything from just standard BMPs, which could be 30 days, or in some cases, just looking for biological activity, which is a shorter test. But we do tests as long as 120 to 150 days to look at life cycle analysis, and basically the first 120, 150 days of a digester startup and how and what issues might occur. And so we do all sorts of variations of tests, trying to make sure that it's as representative as possible to answer as many questions as there are potentially out there, so that during the operations and startup, it's as de-risked as possible for the operators.
Thanks. One of the topics was, looking at, basically, revenue streams, and, that may impact, a project structure, and it gets into maybe an atypical project structure. And I think Chris's project might have some examples how to do that successfully, and, what's non-traditional. And, Chris, how would you maybe structure your projects to be more amenable to what we're talking about with other waste streams?
So the way we think about it is, I came up in project finance, and what you try to do in any kind of good commercial agreement is put the risk in the hands of he who can bear it best, or he or she who can bear it best. And so from our perspective, the introduction of biogas into a municipal wastewater system, adds a lot of new processes and a lot of new kind of commercial operations that are not things that a municipality typically deals with. So when you look on the left of this slide, what do we help with? So investment tax credit monetization hasn't yet talked about here, but if you get a project into construction, as that term is defined by law, this year, you're eligible for 30 to 50% of the capital cost back, which is a big driver, which makes a lot of these projects that would not otherwise be economical. So Burnham helps a municipality navigate that. It's a very complex, spent a lot of money on legal and accounting to try to figure all that out, and to try to figure out how to extend the window of starting construction in order to make these projects work on municipal timescales. So, we think about that a lot for them. As far as interconnection with the gas utility, not something that a typical wastewater treatment plant does. Contracting, for everything we do, we get multiple bids. We'll go out and bid and get the best pricing for the gas and commercial structuring for the gas. We also have been talking to more and more utilities, as I mentioned earlier, about, can we help you to open up a business that accepts liquid waste into your digester to both get tip fees, to also reduce net tip costs, and also increase your gas production. And a lot of municipalities are very interested in that train of thought.
Thanks, Chris. We also, building upon that, right, how do we understand what the potential is for gas production, right? So we'll mention before you can do testing, what's the result of that? Like, what are good waste streams? And, probably depends where you are, and maybe, Will, you can, build upon that and, maybe using some of the data you've developed over your testing, maybe explain, what should people be looking for that could help enhance gas production?
Yeah, so with every project that you're doing, you got to be sensitive to the needs of the operations that you're working with. If you can handle more solids, these higher solids, higher volatile products, like, for example, cheese whey or apple waste sometimes are productive. Just depends on what you're dealing with as far as how much, what you're looking for is high energy content, high solids content, high volatiles content. Generally speaking, is going to give you the best bang for the buck, or the highest yield of energy per ton input. But there's a lot of other variables, from looking at the sulfides and sulfates that are in the feedstocks you're taking, making sure that you're optimizing the system to give you the highest yield and highest energy, just looking at your total chemistry. Sometimes taking something as simple as like a blood waste can increase the cobalt which your microorganisms need, and you can get them for a tipping fee as opposed to paying for it. So different things like that sometimes have values through the process.
Yeah, I think that's pretty interesting. So keep your eyes open, is what I'm hearing, on what's around you for available organic waste streams that could have biogas potential. So, so once you understand what you could be making for gas, right, what do we do with it? Noji. So I guess you had the new day old question of to generate or to not generate. So expand on that, please.
Yeah, I think this is like the common biogas utilization analysis that a lot of folks go through, especially in the municipal space. Do I put in a combined heat and power engine, or do I upgrade my biogas to RNG? And so I guess for some starters, a lot of clients are really interested in attaining energy independence from the grid. I work in California primarily, and that's a huge driver. Also with CHP, you do get heat for the digestion process, and that's a big benefit. Doing cogeneration overall, it does lower the plant's greenhouse gas footprint, and I think plants are becoming more and more attuned to, what their greenhouse gas emissions are, and so that's another driver. One of the downsides I see is that the capital cost is generally higher for the CHP in comparison to RNG. On the gas upgrading to RNG side, I do generally see that there's higher value for the biogas because of pretty stable RIN prices in the last 5 years. One of the downsides for a lot of our clients, they're wastewater treatment plants. They want to meet their permit condition, and doing something with their biogas is not something they're all used to doing. And so making money off of your RINs, we all know it takes compliance and reporting, and some folks are scared of that and finding an off-taker for their gas in the long term. The market uncertainty that we talked about earlier, and another driver, I guess, is if you're interested in an intermediate pathway to hydrogen, I'm seeing some interest there as RNG is a intermediate path. So a lot of times when we do these evaluations, we look at the base case of just using biogas in a boiler on site. You get the lowest value for your biogas that way because you're really just offsetting the natural gas. For on-site cogeneration, depending where you're located and your energy rates, you do have a 40% electrical efficiency and 40% thermal efficiency, so you get more value for your biogas there. And then when you look at the green bars for doing RNG, there's long-term fixed price offtake agreements with anywhere I've seen $13 to $20 per MMBTU. And then if you're doing pipeline injection with Muni Sledge, you'll get the D3 RINs, and so there's pretty high value for the biogas there. And then when you do some co-digestion, you do see more economies of scale because you are producing more gas, but that gas does have a lower value because of the D5 RIN. So this is just kind of something that even though with some clients, there are risks with RNG, we show that there is greater value for the biogas in comparison to other alternatives.
Thanks. I think that's a good summary graph that, could help a lot of us, develop a roadmap for our projects. So thank you for that. And then kind of to wrap things up here, we're talking about what's the future hold, what should we be instilling on people? What's the takeaway here? And we kind of came up with three broad topics here. Educate, test, and develop strong teams. So I'll let the group here kind of chime in on those three topics here, and what we could be doing to help pave a pathway for the future. In no particular order.
Okay, I'll riff off of that. So education process with the municipalities sometimes can be long, but that's something that we take pride in doing. We know that we're kind of at a certain part of the, I guess I'd call it the market adaptation curve kind of thing, right? Where we will go sit down and educate and explain the economics and the benefits, and not just educate, but listen and try to understand kind of what their unique problem set is and how we would recommend potentially solving it. And then as far as team, I think we don't do this stuff in a vacuum. So there's a lot of construction companies and equipment providers here. We like to work with other people, as we talked about in the Pasco project. That's my slide, so I can talk to. I think I've talked to most of this, so I'm not going to take too much more time. But I think if you are trying to get a project in, try to get it in this year. There's a benefit. It can be a tool for economic growth, as it was for Pasco, and by setting this up correctly and help attract large organic waste producers. And then, on my slide, it said Burnham can help with creative solutions to complex challenges, but I would say I think that's probably true for all of the panelists here, Brown and Caldwell, and I know Digester Doc, who I've worked with a lot in the past.
One other thing I would just add is make sure you get your testing on your feedstock. Don't assume anything with your project. Make sure you know what you're dealing with, what the parameters of its digestibility are. Go in there and get some testing to understand what your H2S levels are going to be. One of the most common problems I see in the industry right now is people undersizing their H2S cleanup. And so get an understanding of what your H2S is going to be, get a predictive analysis done, understand what you're going to produce for H2S and size it appropriately. Same thing with your gas yields. Make sure you know how much you're going to be producing so you don't oversize or undersize.
I think in working with municipal clients, I see maybe hesitation to operate new gas equipment or deal with like a pipeline company. And so there are, while you can make more money on your own doing it independently, there are options to evaluate different procurement models and, doing a public-private partnership. I'm sure there's plenty of developers here who would love to get into a municipal project. And so there's always options to explore for biogas projects.
All right. So at that point, that's what we had prepared for you. So we'll open up the floor here for questions, and we'll try to answer it. So we do have good representation, as you've seen, from the science side, help understand what potential there could be from the owner, developer, operator side with Chris, having what project that's very similar that you can learn a lot from as a good case history. And with Noji on the engineering side, forward-facing, lots of municipal clients, getting a good understanding what the market challenges are. So I'll open up the floor, and you can come up to this microphone or shout it out from your seats, whatever you feel comfortable with. Now you got a captive audience of 3 esteemed panelists here for you to ping with questions. All right, sir, in the yellow. You can come up or yell, it's up to you.
Research or initial testing on how you
I can address that. So our Valkyrie Analytics company is designed specifically for those types of things where you're trying to understand the different values of the different feedstocks feeding into a system in real time and what those energy values could be and potentially. So with that, we're able to do real-time analytics to understand all the compositions into the digester and out of the digester, including real-time carbon accounting. With that, we can then look at the values for the BMPs and actually give you an actual accounting to how much energy comes from this fraction versus that fraction and so forth. And so again, through the sciences and doing all of the pieces along the way, you can get those very definitively answered.
Did that address your question? Basically D3, D5 split? Yep. All right, she's gonna do karaoke with us.
I'd rather not yell. Hi, Blair Shrewsbury. I have a question. I come from the renewable diesel space. So a lot of the failed projects on the renewable diesel side have been related, let's call it, people that don't have their CI score pathways aligned, or the feedstock prices that have increased over the last 5 years. So now new into the biogas space, if you're talking about food, people are expected to charge tipping fees or, you know, get feedstocks for free. How much is the risk of those eventually having to pay? People that have the CI score pathways, they go through the regulatory hoops and hurdles and are able to generate more credits on the other end, have better technologies, then start paying for those feedstocks, or at the risk of, you know, the way you guys value a plant or a project, having those inputs become double the price? And is there a rate at that risk that you look at over the next few years?
Sure, I can give that a shot, and if you guys have a view. I'd say, yeah, we do think that the service that we provide is, I mean, RNG is in our company name, but I think really we're an organic waste management company. And so when I look at kind of supply and demand balances, I think there will be more kind of demand for organic waste disposal services over time. You do run the risk with certain feedstocks, right? If it's competitive, I mean, you see it in the dairy and landfill space that people, you know, bid more today than they bid in previous years for the for that feedstock. So in some of those kind of cases, yeah, I think there's bid prices, but I think in traditional waste, source separated organics or things like that, my view at least is that you know, there's probably more upward pressure on prices than downward, but I guess it's certainly possible, and that's a risk. We tend to deal with more contracted projects, but that stuff's hard to contract more than a few years out.
I guess doing a lot of work in California, there is a bill that essentially diverts organics from landfills. And so it's actually, in a way, creating some pressure on the wastewater treatment plants to accept that material as one of the pathways outlined in that bill. Another one is composting. But I guess if other states implement bills like that, I would imagine it would also create upward pricing pressures just because of the supply.
One other thing I would add is, you know, innovation is a big part of that. So as feedstock prices, if they get to a point where you're paying for feedstocks, getting more value out of your feedstock, getting more energy out becomes more important. Maximizing the efficiency of your conversion to energy, going from, say, 30% COD efficiency to 85% efficiency. We have a client that when we started working with them, they were at 15%. Now they're at 80%, and they're producing 5 times more energy than they did when we started with them. So getting that efficiency in there can make a big difference to your economics when prices go up.
All right. Cover that one. Any other questions, comments, concerns? Sir, front row.
In terms of human biological safety or? Okay. So your food wastes that are coming in, generally speaking, as long as your digester operation is contained and you have very set boundaries for where you're doing, if you're in a co-digestion with, say, an animal feed operation and you're trying to prevent biosecurity risks from the animals, making sure that you have set boundaries so that everything stays within this set and that materials as they come on site are processed in a very quick fashion, absolutely within the first 12 hours that it's on site. You process those in a proper way and efficiently, security becomes a non-issue. Where you get risks is when you leave things on site and you start to get more degradation and problems like that that can lead to more hazards.
Any other questions? Okay.
So addressing the grease first, every fats, oils, and grease material has a little different value to them, and everything's not created equal based on where the source is and what's there. Some of it can be like rocket fuel. It can just be amazing for the digester. You want to meter it in, it's like feeding sugar to a child. Too much of a good thing, and by the end of the day, as the parent, you've got a headache. So you just want to make sure that you meter it in properly, manage the digester's biology so it can handle it. If your biology is set up and dense in the digester, meaning it's got a lot of population base, it can handle more types of things like greases on a regular basis. So it depends on what your biology is, but if it's stable enough, you can handle that. What was your other question? Yeah, so composting, I originally started with composting years and years and years ago, and I shifted to anaerobic digestion because for me, composting was not a profit center and didn't have a long-term viable solution package in all conditions. In some conditions, it is. And those two aspects, composting and anaerobic digestion, are very synergetic. If the program is done right, they should complement each other. There are certain things that are better suited for digestion than anaerobic digestion, and vice versa. A lot of the problems that happen with composting is because they try to process things that really shouldn't be composted and are better suited for anaerobic digestion. Does that answer your question? No. Yeah, and it's education, getting people to understand that this is an environment, it's an environmentally friendly activity. It's benefiting, it's displacing fossil fuels. It's that, you can't electrify everything in the world. And so there's still going to be some need for heat. And that's what, at the worst case scenario, what we're able to displace. So it's education.
Yeah, I'd second what Will said. I mean, I'm not dealing with anything nearly as complex as New York City politics, but we have had two discretionary conditional use permits that went in our favor in the last year. And I would say that in both cases, it's obviously outreach, listening, and education. Because I mean, I think the reality is, and I feel strongly about this, that anaerobic digestion is the right thing to do for organic waste, right? I mean, so when you listen to what the concerns are, okay, well, odor, no, because yes, on the receiving, there's things that you need to do to make sure that you're minimizing odor, but actually you're solving some of the odor issues. Safety, I think it's a proven very safe industry. truck traffic, I think, can be managed. It's not the amount of trucks that some people might be envisioning. So yeah, I mean, at least for us, it's been kind of proactive outreach and education has been our tactic.
All right, good stuff. Anything else? Ooh, John.
Yeah, that's a great question, right? So the one that we just showed you, we own the digester and the biogas. So in that case, the incentives are aligned. But we're in plenty of conversations where it would be the other way. And I'll tell you that we've chosen simplicity over perfect alignment, meaning that, outside of setting aside the food waste, there's some predictability in the gas, but not full. And I think there are stories of others that have been in a situation that I hope not to be in, where the digester is operating not very well and you're getting less gas. And so we tend to take that risk. We tend to pay a royalty-based model. We put certain clauses in the contract that will require them to operate with, prudent industry practices and other things like that. But we're not in a position where we are, recommending penalties to the municipality if they don't produce and that kind of stuff, because I think that just would start us out on an adversarial way. So we are taking that risk. We've had certain models that, could align economic incentives differently, but that's reality how we've dealt with it.
That sounds like the long definition was smart city, Chris, was my take on that. So any other questions? Otherwise, we're giving you back a couple minutes of your life to use the restroom. How about that? All right, thank you, panel.